And we have a symbol for rational numbers, the Q symbol. So a rational number can be in this form, A over B. Right? They can be two letters, A over B, and these letters are numbers. And B just cannot be 0. So you can't have a number like 2 over 0, because that'll be undefined. So you can have a 0 in the numerator, but you can't have a 0 in the denominator. So again, A just means any number, B means any number, as long as B is not 0. And then you'll have a rational number. So rational numbers have to do a few things. So, one, rational numbers are integers. They are fractions. And guess what? They're also decimals. And all rational numbers can be made into decimals. And the decimals have to do a few things. So let's look at a few. Alright, so we said rational numbers have to be made into decimals. So if I had like 2/5, for example. So we can make 2/5 into a decimal. We just bring down the numerator. 5 does not go into 2, so we put dot 0 extend. And 5 goes into 24 times, right? So it's 0.4. And 0.4 terminates. It stops. So if a decimal terminates, in other words, it stops, then it's rational. It's a rational number because it stops, 0.4. So remember, terminate means it stops, it ends. So if I have a decimal like this, like 0.434343, well, that's just repeating with a pattern. The pattern is 434343. So you can just put a 0.43 with a line on top of the bar. And this is a rational number also because it repeats with a pattern. So that's the key for rational numbers. They have to have a pattern that repeats. Not just a pattern, but the pattern has to repeat. So if I said 0.412412, well, that pattern repeats back to 4. And that'll be 0.412 with a bar on top of it. Those are rational numbers. But some numbers, like the famous pi, right? Pi is not rational because it does not repeat. Doesn't even have any type of pattern as we know of yet, right? So this just keeps going, there's no pattern, and so forth. Now, what may look like, a number may look like it has a pattern, for example, like this. This may look like it has some pattern, right? And there is a certain pattern here. Well, let me just put another 0 there. Dot, dot, dot. Now, what's happening here is it seems as if that, the next one in the sequence will be 0000001. Right, that's a pattern. There is a pattern here. But the problem is the pattern does not repeat back to 0, 1. If it did, this would be rational. But because the pattern does not repeat, this is not rational. And sometimes they put this Q with a 1 on top of it to say it's not rational. So again, rational numbers have to either terminate like we did here, or they have to repeat with a pattern. If they don't repeat with a pattern, then it's irrational. And we'll talk about irrational numbers in another time. So here's pi is a irrational number. Phi is an irrational number. Any square roots we'll talk about later, like the square root of 2 is irrational. These are all irrational numbers. And so let me do a few more rational numbers. All right, let's try another color. Let me use purple. Right. So again, if I make a fraction like 7 over 9, well, we know that 7 over 9 can be rational if we can make it a decimal, which we can. Just bring down the 7. 9 doesn't go into 7, so we put dot 0, extend the bar. So 9 goes into 70 7 times, and that's 63. And what's going to happen here is it's going to continuously be 0.7. So this is 0.7 with a bar, and we know that it repeats 777 always, so this is rational, Q. Now what if you had something strange? What if you had 0.3 over 5? That's kind of strange. Well, you do the same thing. Just put the 0.3, put the numerator in the box. So, and then bring that decimal up. 5 doesn't go into 3, so it's 0, right? Right? And then what you'll have here is just add another 0. 5 goes into 30, and there's your answer, 0.06. If you want to finish it off, 0 times 5 is 0. And you bring down the 3, and there's our 30, and that's why we got the 0.06. 0.06. And 0.06 terminates. So this terminates, so it's rational. And this repeats with a pattern. It keeps going 0.7, like we said. Also, 0.3 over 5 is interesting too, because 0.3 over 5 is also 3/10 over 5. And that's a complex fraction. This is complex, and we'll do more complex fractions. So this is complex. When you see something like this, the numerator, you put the numerator and you divide it by the denominator, which is 5 over 1. And of course with division it's keep, change, flip, right? You change the multiplication and you flip it, and it just becomes 3/50, which is exactly that, 0.06. So we'll do more complex fractions. So remember, a Q is a symbol for a rational number. Rational numbers are integers. They are fractions and they are decimals, and they all need to be made into fractions. But one more, if we had like a 5. 5's an integer. So 5 is 5 over 1. Right? How can you make that a fraction? Well, 1 goes in the 5 times. 5.0 is the decimal. 5.0. It terminated. It ended. Alright, that's our video for today. Great job.